Wi-Fi, it kind of feels like invisible magic, right? It just holds our entire digital world together. But we've all been there. That moment of pure frustration when your connection just drops in the middle of something important, or when you pull a new router out of the box and it just looks, well, completely overwhelming. Well, that feeling is exactly what we're going to tackle. We are going to demystify Wi-Fi by really diving into the fundamentals of how these networks get set up, how they're managed, and most importantly, how to fix them when they go wrong. Let's get into it. So, here's our roadmap for today. We're going to start with the home network that you know and love, then scale all the way up to the massive systems that power big organizations, and then we'll get our hands dirty and figure out how to fix things when they break. All right, let's begin where most of us use Wi-Fi every single day, at home. That single box you probably got from your internet provider, that's a pretty clever device called an integrated router. It's actually a switch, an internet connection, and a wireless access point all crammed into one convenient package. So you just unboxed it. The first thing you do, and I mean before anything else, is log in and change that default password. Seriously, this is not negotiable. Default login details are often public knowledge online, so not changing it is basically like leaving your front door wide open. It is the single most critical security step you can take. Now, your router is doing some serious work behind the scenes, and one of its most critical jobs is something called Network Address Translation, or NAT. Honestly, NAT is the unsung hero that lets your phone, your laptop, your TV, and everything else get on the internet at the same time, even though your provider only gave you one public IP address to work with. A really great way to think about NAT is to imagine it's the receptionist for your whole network. It takes all the requests from your different devices and makes them look like they're all coming from one single address. It keeps track of who asked for what so the right data gets back to the right device. And as a bonus, it adds a really nice layer of security by hiding your internal network from the outside world. Your router also has some other superpowers you can play with. There's quality of service, or QoS, which lets you tell your router to prioritize your video calls so they don't get all choppy. You've got port forwarding and triggering, which let you open up specific pathways for things like online gaming. And if you've got Wi-Fi dead zones, a wireless mesh network can extend your coverage seamlessly through the whole house. Okay, so that's the home setup. Pretty manageable. But what if you're managing Wi-Fi for an entire university campus? Or a giant corporate office? You're definitely not going to walk around and configure hundreds of access points one by one. This is where the whole approach just flips on its head. It's a total paradigm shift. Instead of those smart all-in-one boxes we have at home, large networks use what are called lightweight access points. They don't have their own brain. Instead, they get all their instructions from one central controller. And that central brain is called the Wireless LAN Controller, or WLC. This thing is the puppet master, all the heavy lifting, every configuration setting, all the security policies, which channels to use, it's all handled right here. So when you need to add a new access point, you just plug it in, it boots up, finds the WLC, and boom, it gets all its settings automatically. It's a wildly efficient way to manage a huge network. Now, with that many people on the network, security also needs a major upgrade. In a business, having everyone share the same Wi-Fi password is a gigantic liability. You need something way more robust. And the key difference here is between WPA2 Personal, what you use at home, and WPA2 Enterprise. With a shared password, if someone leaves the company, you can't easily kick them off the network. Plus, you have no idea who is doing what. Enterprise mode fixes this by giving every single user their own unique username and password. All this magic is made possible by a Radius server, which provides a critical framework we call AAA. It's easy to remember. Authentication, which asks, are you who you say you are? Authorization, which asks, okay, what are you allowed to do? And accounting, which says, we're going to log what you did. It's security and accountability all in one. But let's be real. No matter how well designed a network is, problems are going to happen. It's just a fact of life. The key isn't to just start randomly clicking things and hope for the best. It's to have a systematic, logical process for finding the root cause and fixing it for good. And this is it. This is the secret sauce. A powerful 6-step framework that's basically the scientific method for your network. You identify the real problem, come up with a theory about what's causing it, test your theory, create a plan and implement the fix, make sure it actually worked, and finally, you document everything. This turns pure chaos into a clear plan of attack. Okay, enough theory. Let's apply this mindset to a couple of the most common Wi-Fi headaches we all face. Having absolutely no connectivity or having a network that's just painfully slow. So if you can't connect, don't panic. Start methodically. First theory is the problem with my device. Check your IP settings. Make sure your Wi-Fi drivers are updated. Okay, if that's all good, next theory, did I make a simple mistake? Double check that network name. Are you absolutely positive there isn't a typo in the password? From there, you start working your way up the chain. Is the access point even powered on? Are the cables plugged in all the way? Now, what about a slow network? This one's fascinating. Here's a surprising culprit. A single, older device using an old Wi-Fi standard can literally drag down the performance for everyone else connected to that same access point. Why? Because the access point has to slow its own communication way down to be compatible with the slowest device it's talking to. A fantastic strategy to combat this is to split your devices. Think of the 2.4 gigahertz band as a crowded two-lane road. It has long range, but it's slow and gets tons of interference from microwaves, Bluetooth, you name it. The 5 gigahertz band is like a clean, wide-open superhighway. It has a shorter range, but it's way, way faster. So put your speed-hungry devices on 5 gigahertz and leave the older, slower ones on 2.4. And here's a fundamental rule for a healthy network. Whether you're fighting slowness or just trying to stay safe, always keep your firmware updated. These updates aren't just annoying notifications. They're packed with performance boosts, bug fixes, and most importantly, critical patches that plug up security holes. So we've really gone on a journey here, from that all-in-one box at home to the central brains of a massive enterprise network. We've seen that reliable, secure Wi-Fi doesn't just happen by magic. It's the result of smart configuration, deliberate management, and having a logical approach when things go wrong. Understanding these principles isn't just trivia, it's empowering. It fundamentally changes how you see the wireless world. So I'll leave you with this final thought. Now that the magic has been decoded, how are you going to use this new knowledge to build a better, faster, and more secure network for yourself?